Today we're going to talk about distance. Okay, if we consider a straight line between 2 points, okay, we will say that that line is automatically the shortest distance. Kind of makes sense. I always say, like, would you rather cross a lake in a boat or would you rather walk north and then cross a bridge? You'd probably say, I'll take the boat ride. It's going to be shorter. All right, we say that a straight line between 2 points is the shortest distance. So what do we mean by distance? Okay, we're always going to measure distance positively. The example I like to use with my students is if you've seen the movie Ferris Bueller's Day Off, they borrow Cameron's dad's Ferrari, and Ferris says, don't worry about it when we get back. Just run the car in reverse. It'll take the miles off. But of course, that doesn't work because whether you're traveling forwards or backwards, the distance that you've traveled, we always measure positively. So now that we've got that out of the way, let's talk about what it looks like. We need coordinates, okay? When I ask what strategies come to mind, what I am normally looking for is that I typically will have students be like, well, can I just count my way up? And I would say, if you had a vertical line, sure. And if you had a horizontal line, sure. But that's not what we have, okay? We have this line on a diagonal. We need to be careful because, and we'll get into this more when we get into triangles, but going up 1 and over 1 does not have a horizontal distance of 1. That this distance right here is not 1. So you can't count on a diagonal like that. You need to find some other strategy, some other method that will get us the distance between these points. And that's this formula right here. Normally, I don't like introducing formulas or theorems without proving them to you, but until we talk about the Pythagorean theorem and how they're connected, for now I'm just going to say, unfortunately, this is something you just have to learn how to work with. To find the distance, you take the square root of the distance, the difference of the x's squared plus the difference of the y's squared. So basically, what's the distance that you traveled horizontally? Find that difference and square it. What's the distance that you traveled vertically? Find that difference and square it, and then take the square root of both once you've totaled it together. I want to make sure we talk about radicals really quick. Radicals, that's the square root symbol, okay? What I like to remind my students, and we probably covered this in Algebra 1, is that if you have some large number in there, you can always split it up to be the square root of 1 and the square root of another, and that's very, very useful when we find ourselves in a situation where I am able to break it off and have a perfect square here. Right? So an example I might like to use would be something like 24. Right? Could I split this into 12 and 2? Of course I could, and it's still true. It's just not very helpful to me. It's just not very helpful for me to do that. Instead, I think I might go for saying 4 and 6. Those are both factors, but the reason that's a little bit more helpful for me is that 4 is actually a perfect square, so that I can convert the square root of 4 to just being 2 root 6. This is as exact of an answer as I want you to give me when we talk about distances in this class. I don't really want you punching this into your calculator and giving me a decimal answer. Okay. So let's actually work on this practice problem right here. So the first thing that we need to look for is identify x and x right here. And then let's identify y and y right here. And now let's get to work. I call these, I understand that you might not love this equation, but I kind of call these problems like plug and chug. There's not much complication I can really add to these other than maybe a word problem or something, but really we just got to get the information into this formula. So x minus x, 6 minus 0. And when I'm done with that, I'm going to square it. And I need to add to that the same process, but for my y's. So 6 minus negative 2 squared. So this is going to become taking the square root of 6 squared plus 8 squared, which is 36 plus 64. And look at that, because Mr. Card is awesome. He picked a nice, easy example to get started where we have a perfect square. The square root of 100 is 10. And maybe you're wicked smart and you're like, well, couldn't it also be negative 10? And I would say that's true, except that, like we said, it's a distance. So we can just sort of discard the negative answer. We only measure distance positively. So that's our first example problem of many more. All right, I'll skip these for now. And I want to talk about this word problem here, okay? This word problem is probably the most complicated I can make it because you still need to take this information and put it in the formula, and then I tell you to assume that each unit on this grid system represents a fifth of a mile, so a little conversion. That's about as complicated as it can get, guys. Otherwise, it stays pretty much in this zone of, hey, here's 2 points. Can you plug them into the formula and get to work? All right. But for now, that's all I wanted to talk about. And I'll wrap this video up.